Good morning. How are you guys doing today? Why do I always ask that when I know I can't hear you? I don't know. It feels normal, I guess. Okay, so today we're doing the second half of 7.2, which means we're talking about p-values. It's very similar to rejection regions, so it shouldn't be too hard. We're going to start with the same thing I did last time, where I'm going to do the chart that you guys like here. I'm assuming you still like it since I don't have any real feedback. And then we're going to do example 3 at the exact same time. I know that they were a little out of order in the notes, my bad. I was scanning them and didn't bother to rescan in the correct order because I didn't want to. So, alright. So step 1 is the same thing as before. You've got to verify that you can do this. Which means you need to make sure that the sigma, the population standard deviation, is known and that it's normal, or by using the central limit theorem, if n is greater than or equal to 30. So either one's good. Alright, that is in the problem, so you don't have to do any extra work there. Alright, so let's go back and forth. Example 1. Okay, so let's see. In auto racing, a pit stop is where a racing vehicle stops for new tires, fuel repair, and other mechanical adjustments. Efficiency of a pit crew that makes these adjustments can affect the outcome of a race. A pit crew claims that its mean pit stop time for 4 new tires and fuel is less than 13 seconds in a random sample of 32. Okay, so we know that there's 32, so it doesn't even have to be normal. Has a sample mean of 12.9 seconds. Assume that the population standard deviation is 0.19. If you didn't know the population standard deviation, you could do a T hypothesis test, which is what we'll be doing next time. So, step 2. Step 2, just like before, is to identify the null and alternative hypothesis. H sub O, H sub A, and either could be the claim. Okay. So step 2 here, H sub O, H sub A. So they said that their guess was that the mean, or their claim was that the mean pit stop time is less than 13 seconds, which means the opposite is that it's greater than or equal to 13, so there's the claim. Okay. Step 3. Find the level of significance. That's in the problem, that's just alpha. And the standardized test statistic. And that is the same formula we used last time, x bar minus mu over sigma divided by the square root of n. X minus mu over sigma. Okay, so going back to the other sheet. Number 3, again, that formula was x bar minus mu divided by sigma divided by the square root of n. So for this one, x bar is 12.9 is what their sample stat is. Mu is just what your claim was back here. And then 0.19 for that sigma divided by the square root of 32. And if you do that math, you end up with a z-score of negative 2.98. Alright, so here's the difference between rejection regions and p-values. p-values compare area. This is the biggest thing, so pay attention right now, maybe take some extra notes. P compares area, where rejection regions compare the z-scores, and that's it. That's the only difference. So in this one, we're going to be comparing our p-value to alpha and seeing if we're going to accept or reject. So for step 4, you need to find the p-value. Okay, so if it's a left-tailed test, it is the area to the left of z. If it's a right-tailed test, it's the area to the right of z. And if it's a two-tailed test, then it's the area to the left multiplied by 2. Okay. Pause if you need time. Alright, so this test is a left-tailed test because it's a less than test, right? So that means it's less than over here. This area is 0.05. We don't need to look up a z-score and compare it because we're using areas, not rejection regions. So then if I look up in my chart, A16, A17, what the area to the left, because I'm trying to find the p-value for this, and it's a left-tailed test, so I'm trying to find the p-value of negative 2.98. Alright, so if I look up in my chart, negative 2.98 is 0.0014. So that's what I've got to look up. And I did. So my p-value equals 0.0014. So if you kind of think about that, that is like a little tiny area compared to this. And if we were doing a rejection region, it would definitely be falling in that rejection region. You see? So, going back to our plan, step 5 is to accept or reject the null, not of, or reject the null. And our last step will be to accept or reject. Man, that is so annoying today. I did not write that in my notes. This is just a fun mistake that I decided to start making on a video. Alright, so accept or reject the claim. And remember, the claim isn't necessarily the same thing as the null, and it's not necessarily the opposite of the null. It depends on the problem. Alright, so here's how you can tell. If p is less than or equal to alpha, then you reject the null. Remember, you always think about the null first. Otherwise, accept it. And when you're talking about the claim, you need to have a sentence with context. And remember, context is just like talking about what it means for the story problem. So I'm going to scoot up my notes here so you can see the whole thing at once. Pause it if you need some time to make sure to write this stuff down. Pause, 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 pause. Okay. So, going back to here. Alright, 5. So again, if p is less than or equal to alpha, we reject